Yes, neural network foundation, the introduction of linear algebra. Before going into it, we'll see what is algebra. It means it's a branch of mathematics uses symbols, letters, and numbers to represent relationships and solve equations. So in this expression, we have x plus 3 is equal to 7, where x is the variable, 3 is the constant. By putting the 3 over here, so x equal to 7 minus 3, where the value of x is 4. So mainly algebra is used to solve problems where values are unknown. We'll come into linear algebra. What happens in linear algebra is we have vectors, matrices and transformations. So in vector, what happens? It deals with the direction and magnitude. So 3, 4, where u vector is 2, 3, v vector is minus 1 and 1. So adding these u and v vector results in 2 plus minus 1, which is 1. 3 plus 1 is 4. And we have this vector space. What vector space is? The collection of vectors which is being added or scaled. So say for example, we can use it in the GPS location, as we can able to see the latitude, longitude, which is having some two values to get a direction. And we'll come to matrices. So in matrices, say for example, we have 1, 2, 3, 4 and 2, 0, 1, 3. When added, it's the direct summation, like 1 plus 2 is 3, 2 plus 0 is 2, 3 plus 1 is 4, and 4 plus 3 is 7. So when multiplied, what happens? It's like we have to multiply and add. So say for example, on this one, 1 into 2 plus 2 plus 1 into 2 plus 2 into 1, which is 2 plus 2, 4, and 1 into 0 plus 2 into 3. So 0 plus 6 is 6. So 3 into 2 plus 4 into 1. So this is 6 plus 4, 10. And then 3 into 0 plus 4 into 3. So 0 plus 12 is 12. And then we come into linear transformations, which is on rotation, reflection and scaling. Rotation and reflection, it's like in the x and y axis. Whatever happens in the x axis, we'll try to put it in the y axis as a reflection. In linear equations, what we are trying to do is ax plus by is the c. Ax plus by plus c. From this equation, a, b, c are constant and x, y are variables. Say for example, in this expression x plus 2y equal to 5, 3x minus y equal to 1. From these two expressions, we can able to find the value of x and y by substitution or elimination method. We can find the value of x and y on these linear equations. So we'll come into determinant and inverse. So what happens? A into A inverse equal to I, which is the identity matrix. And to find the determinant, if we have the value of A in as A, B, C, D, determinant of A is A into D minus B into C. So we'll come into eigenvalue and eigenvector. So what happens? AB equal to lambda B. A is the matrix, B is the vector, lambda is the value. So what happens? The eigenvector it doesn't change when transformed. It's like it will be remain same. So eigenvalue is the value which is the scaling factor, which has the lambda value. So this is like the introduction of linear algebra, and where because this being the base and foundation to these concepts like colors, RGB. So when we have an image, we will have the RGB color like 0 to 255. We can apply on the image filtration. Say for example, we have a color photo, we want it in black and white. Once we change the pixel value of the RGB color, we get the different image. So it's used in the back propagation, linear regression, PCA, weights, activations. In CNN, it determines the strength of convolution filter. It's used in computer graphics, 3D transformations, neural networks, and more. Thank you.